Today I'm feeling super sleepy and we are going to be doing type systems, so I don't know how this is going to go. But let's do it. Let's do it then. Yeah, I guess let's go to here. And maybe we can clean up a little bit of this mess. We had it like this before because we were not able to call C functions with inline assembly, but now we fixed it. So we should be able to call C functions. And in that case, let's do the following. Let's extract the word compilation into a separate function. Yeah, so we can have something like, I don't know, void compile words, right? Something like this. We can have another function with something like quotes, right? Compile quotes, compile array, and we can have also the immediate version, right? So it's not really compile, it's going to be void, I don't know, immediate word. In this case, it's going to be like compile definition or something, because it's called like a colon definition. Yeah, we can change the names later, but like this is going to be probably enough. So we can start moving this shit into proper functions and not pollute the entire file. So what do we want? So let's assume here we arrived here because like the current word is basically the colon, right? So now we just need to copy this sheet. Where was it? This one? Yeah. We just need to copy this stuff. Yeah, I don't even know if we need compiled word, to be honest. I think we can just directly append. Yeah, we probably don't need it, but sure, let's just copy this. This is compile definition, right? And then, so where the fuck was it? You see like how confusing this shit is? Yeah, here I called, okay, next. Okay, but then my compiled words, oh, I do vocabulary add. Why do I do vocabulary add? Oh, yeah, okay, okay. So can I instead do the following? Like I don't want to manage this with a function. I can do vocabulary reserve, right? Something like this, which is going to do all of that shit and not do this, right? So it's just going to allocate memory if needed. Yeah, I think that's the best thing. So we can begin by reserving a slot. Well, we can even say, yeah, we know that we're only going to reserve one at a time, so it's okay. Then I can go to my vocabulary and I can say vocabulary dot count. Oh yeah, I have it like this. Okay. So I can even do something like prettier. I can say here I can call it words, right? should I call it appends or should I not call it appends? How do you call an operation that appends an empty value? Like, that's a good question. In programming languages, how do you call an operation that appends an empty value and returns a pointer to it? Okay, allocate appends and return reserve and appends. Yeah, I'm just gonna call it appends. Yeah, why not? So this is going to appends, and this is going to return me a pointer to a word, right? To the word that was just appended. And then, so here, what I basically need to do is word results needs to be that, then vocabulary.count, right? Like this. Why don't you like it? Oh, it needs a pointer to it. Sure. Then I need to increment vocabulary counts, and then I can return the results, right? And here I can even make this slightly, well, I always need to allocate it, so there is nothing I can do actually. Okay, cool. So here I can do append, and I can say that this is my word. Okay, cool. So now my word is that. Then I can do the following: word dot sure, words. It's a bit weird, but sure. It's going to be next, right? It's basically going to be this one. Oh yeah, I need to fuck. Okay, so I can say my words becomes char pointer. It's going to be equal to that. And then why did I? Oh yeah. Well, yeah, because I need mem copy. Okay. So I can also have size t n str length, right? Str length of the words. I can call this s and I can call this word. Okay. Yeah. So this is ns n plus 1. Next, this is actually s, right? And then we do that. Okay. Here is my word. Okay. Then the word address is equal to bumpy, right? So I prefer to work with pointers rather than having so many functions. Yeah, so we are initializing that. Then since we want types, right? So do compile definition compiles like constructs, or compiles basically this stuff: name, type, dot, then this, and then type dot dot dot. Okay, basically compiles this kind of shit. Let's put it there. It's, yeah, I can even say, yeah, I guess, whatever. And then yeah, this is a body, and then stuff. Right. So basically, this is what it compiles. Following construct. Something like this. All right. And so since this is only actually used, like this inline thingy, yeah, inline threshold is actually in use there. Maybe we can put it upwards, like, Yeah, because this is a configuration of the compiler, we can put it there and we can keep doing our shit. Okay, so now, so we compiled the name, we are here, we already consumed that, we consumed that, we now expect this, right? So yeah, I guess we can say the following. Next, and we can say if strEq, so if it is not equal to this, like this, you can basically report an error and say printf error expected. How can I expect that type or like, how do you call this shit? Man, today I already warned you, like today I'm super sleepy. In concatenative languages, how do you call the type thing in WordDef? It's not really stack effect. We can call it stack effect. Like, isn't stack effect just for arity? So I mean, I thought this was like more for Prolog stuff, like the arity. Oh, it encodes both arity and the types. Okay, okay. So yeah, expected stack effect. How do you write it? Okay, stacked effect after word name, or actually in words definition. Something like this. Something like this. Cool. So we did that. We can even return like this. Then, so we know for sure that we have that. Then we keep compiling shit until we find this one. So we can say while next, well, we can have like a const char t for type, and that one, and you can say strq t is not equal to that, or like it can be misformed, right? Should I worry about that? I mean, let's just keep it like that. Okay. So while it's that, we need to do type stuff, right? So if we go to our words, let's do the following. Enum. So for now, we are only going to have primitive types, so no support for user built-in types. So we can say type, and you can have type int, I guess. Do I support any other type besides type int? Oh yeah, I do actually. I support type address, right? And I support type array, right? Well, I can even say quotes. I don't know how I'm going to handle that, but yeah, sure. And then I have type array. Yeah, how am I supposed to handle quotes? Because like quotes can also have a stack effect. So am I supposed to have something like, okay, so we have name, and then if I'm supposed to have a quote, should I like have this like this? So I can have like int, then this, then int or something, and then I can have like this and have int or something like this. I don't know if this is going to be too confusing, to be honest. Let's see how it goes. But yeah, so where is it? So let's keep it like this, and quotes we can handle afterwards because it may be a little bit harder. Yeah, and here we basically are just going to have type with ins or inputs. I don't feel like having dynamic arrays here, so let's just hardcode this to 256. I don't know. And then output. Fuck. Okay, I'm gonna have a dynamic array. Type def struct types. Okay. Here we have data size t count and size t capacity. Right. Yeah. So here we should actually make sure. I don't know if this returns it. Let's do the following. Memset. Okay, memset results to 0 size of words. Okay, just to make sure that it is here initialized. So we have data count capacity. Okay, and here we can simply have types for inputs and types for outputs, like this. All right. So what else do I need? Well, I could have functionalities. I'm trying to avoid to not have the macro, so people do not complain, because I already had comments, people complaining that I use the macro for dynamic arrays. So let me try to avoid it, guys. Let me try to avoid it. So types here, I can actually append the type directly. I don't see a reason that I need to return it like that. So void type t, and here we simply say, oh fuck yeah, here we also need to set the pointer to this, something like that, and then the type itself. So we need to say that it all needs to be, yeah. And here, like the default, it can be like 8 or something. I do not expect to have that many types in a single thing. So all right, then I can say that, and here I can just copy t and everything is fine. Cool. So yeah, I do that, and then while it is not a closing thing, I can say the following. So this is a boolean is input. Initially it is true, right? Then if t str eq t is equal to that, because that's generally what in like in concatenative languages, that's generally what separates the input from the output. I can swap this to false, and I can continue. I can continue. So I can even say the following. Yeah, so why not say for and place all of that inside, so it's a little bit more compact. I do that, and then I can say t and that, and then I can say t equals next, like this. Okay, so if it is that, we swap the thingy, we continue. Otherwise, well, we can even do something, yeah, we can even do something like the current types or something. Right? So this is types, and we can have it like a pointer, and it begins by being the inputs, like this. And if it is that, we can change current types to being words output. So it's even even better, like this. Because now we can actually make it shorter, because we can say if strq so t, if t is equal to int, then we can just do types underscore append, like so, and here we provide the current types, and we just provide type int, right? Else if yeah, else if I can just copy off that sheet. Else if it is an array. How am I going to, well, I can say this shit, right? I can say that in the future I may be I may want to add stuff here. So let's have a file like demo. So let's say I have a word called reduce, right? So reduce, and reduce needs to accept an array of integers, something like this, and it's going to do that, right? Or I can even call it sum. Okay, so this is going to sum all the integers inside the array. I can even declare this to be an integer array. But for now, let's say this. Yeah, let's try to keep it as simple as possible. But if it was an integer array, the only thing we would need to do, so this would be the address, then we would need to push 0. Oh, sorry. We need to push 0. Well, we could actually do length, or actually dup length. So we would have the pointer to the array, the length of the array. We could do 0 swap, right? So we will have from 0 to up to the length, and then we could have a quote, right? And here we would have the index of the array that we want. Well, we would need also an accumulator, right? So let's push the accumulator. Actually, fuck, let's push the accumulator there. So swap, right? So dup 0 swap gets the pointer above, so we have length 0 swap, then we have the pointer and then the accumulator. So now we have the index, and having the index, we can just do something like at or something. Let's presume. Oh, but by the way, so we have dup 0 swap. Yeah, so we need to do swap here. Oh fuck, we actually need to do over. Or over, or even rot. Wait, so when I arrive here, I'm gonna have the address, I'm gonna have the accumulator, right? And I'm gonna have the index. But I wanna push this shit. So yeah, I need rot actually. So I can say rot. So this shit gets there, right? Then I can say at, which would consume this. But I do not want for that to be consumed, right? So if I have that, I can rotate in the other direction. Well, that's not very useful, to be honest. So let's assume I rotate like this. So I can do then swap, right? I can do something like swap. Then I can do over, which is going to bring the address there. Then I can do at, which is going to give me the value, right? Then I can do swap, which is going to put me like this, right? Or actually no. Then I can do rot actually. So I do rot, which is going to put me like this. Then I can sum like that. And we get back to the initial state. So this would be the implementation, and then we'll do for. So this would be the implementation to sum all the elements of an array and reduce them with sum. This is very non-optimal, so I still need to get into the mindset of concatenative languages, but anyways, we can do this, and you can push an array. And for now, we are only going to support int and array. I still need to think about quotes. Sure. So we do this sheet. We do this sheet, and then we finish that sheet. So we got here. We make sure, yeah, that's done. So now we need to do the body, and the body is more or less what we already have, so I don't need it anymore. So yeah, I just need to do a similar thing. So this is, yeah, this in this case it won't be the words, and while it is not the return, like so, we need to keep looping. And if we are looping, we can just say that, right? Yeah, we just need to say that. But in this case, we assume, yeah, in this case we are in, oh fuck, yeah. Okay, so let's don't care, yeah, let's not care about that. Let's just assume we are in compilation mode. Everything else is useless to us, right? Everything else is useless. Here we can continue, correct. Here we may even extract this like that. What else? What else? Then I don't even know why. Oh yeah, we found a primitive. Okay, okay. Sure, we can copy this code and put it there. And here we assume we are in compilation mode, so we don't need to handle multiple cases. We just need to handle that, like so. Then what else we have? Here we just need literally this case, because we cannot compile or define a word inside the word. That doesn't make much sense when actually we have quotes, so it even makes less sense. So I can just do that. Use that inside a word definition. Okay, so that's an error, and we can return immediately. What else? So that. So if we found, yeah, but if we found that this would be outside already of the loop, and we wouldn't. Oh yeah, we just need to compile the word size. Okay, okay. So outside of the loop, like we assume we reached that, right? Or no. So we just need to check if word, or if not word in this case. Oh fuck, but this word, okay, let's define it there in that case. So we just need to do that. Okay, so if not word, then we can say something like expected that at the end of a word definition. And here we are 100% sure that we reached the end, so word is equal to that, and word bam bam, something like this. This is a pointer, if I'm not mistaken, like this. Okay, it makes sense. All right. So, but let's keep going in there. So we handle that case, that's already handled. We need to handle quotes. To handle quotes, I think we can call the separate function. So if we reached here, can do else if we reach that, we can just call compile quotes, right? And the compile quotes, yeah, the compile quote is going to do the same thing, right? It's going to just keep writing codes. Oh yeah, fuck, but it changes if we are in compilation mode or outside of compilation mode. Fuck. Yeah, exactly. Exactly. So we need to keep a global variable of that shit. Okay. So here we can just say bool inside is compiling definition. Something like this. Yeah, we need to keep it like that. Okay. So here we just need to trigger this as we go. Right? And then every time, do I want to remove it once? I can like, yeah, fuck it. I can leave it like that. I can just set it at the ends as false. Okay. And here we assume that this is going to work because of that. So it's okay. Then that function is only going to check for this, I assume. Then if we reach this, then we need to compile an array, right? And here again we need to check that sheet. Okay. So here if we reach that, we can just call the compile array function. This. Else we are at the very end, we can simply say yeah, this is like a debug stuff. I'm gonna keep it like this. I'm not even going to worry about it. We can copy this, and here we are in compilation mode. We can assume that, so we can say, yeah, if we can return here. So if the word was not found, so we can simplify all of these sheets and just put it like this. Okay. So yeah, so this is an inlining mechanism that we have. Okay. Cool. And I think that basically handles the entire compile definition. I'm gonna say compile word. Fuck, I don't like this name. So compile words, and here I'm gonna call it compile words. Okay. So after that, let's handle the first dependency, which is this one, compile quotes. Okay. So when we reach this state, we already know that we collected at least the curly brace, right? So in that case, let's do the following. Yeah, we can keep this in a global variable, I guess. Yeah, sure. We can keep it there for now. Then if we are compiling a quote, it's basically the same code, isn't it? It's literally basically the same code. Right, I don't think let me take a look. So if we are inside word compilation mode, we need, yeah, we need this header. Okay, so we can do this sheet. And here, yeah, we cannot really distinguish that, so let's do this. So here, oh, I don't even fucking, let's extract the literal there. Yeah. Well, it's actually only going to be used here, so okay. We can do this, and is compiling word. So if it is compiling a word or is inside another quote, we need to do all of this shit, which is okay. Otherwise, you can just push a literal directly. Okay. But after that, the loop is almost the same, right? The loop is almost the same. Huh. Which makes me think that we could extract it, that we could extract all of these shit. Yeah, let's create a function. So void compile we can just call it compile. Why not? We can call it compile codes. Yeah. And this is a word. And here we just do this shit. So we can assume, yeah, we just do all of this shit and yoink that, place it there. Fuck. What, man? I swear. This. Okay. And here you can actually get even simpler because now we no longer need this shit. We can simply return directly. Like so. We don't need that. Here we are compiling codes, right? So this is going to be recursive, it's fine. This is going to be recursive, it's fine. We're returning, return. I mean, everything is fine, to be honest. Here we just return. Yeah, a lot easier. So here, oh fuck, I need P. Where is my P? It's here. Okay. So we can share, well, we can leave here. We can share all of these codes, right? So here I just say compile words, compile code and compile that word. So this code is all going to be the same, right? So here I just do that shit, cool. And here I do this, but while I don't get this shit. So this is the termination character for the quotes. And here we say we reach that or null. Here I can say expected that at the end of the quotes. And here I can actually improve the error codes inside code compilation mode. Yeah, why not? Inside code compilation mode, and then here unknown words. Yeah, all the errors are okay. That's very nice. All right, so here we do that sheet. We do this sheet. Here, okay. Now we just need to terminate the quotes, and to terminate, I think we only need to patch some shit, right? Where was it? Yeah, here. So, yeah, I guess we just need to do this shit. Literally just copy paste. Okay, that's very nice. So it's simple and straightforward. Okay, so we can do that, and this is the entire compile code implementation. Yeah, exactly. Let's go for compile array. Yep, compile array. So when we reach compile array, we can assume that we have already parsed this sheet, right? So in that case, oh yeah, I'll need all of these sheets. I need all of these sheets. Okay, so let's do the following. but I just need these two. I think I just need those two actually, because I'm not going to allow any other stuff inside the array besides numbers, so I don't need global variables or anything. And so there we need a similar thing. Where is my loop? It's here. We need that, and here is a termination thing, but here we just need to copy this shit, right? Yeah, so let's copy this. Actually, let's copy all of this. And here, if it is not all digits, we can just say that. So error, only numbers are supported inside arrays. Got something. Okay. Then if it is a digit, if it is something like that, we can just do this. So we extract the number, we extract the array size, we append that to the data segment. Here we don't care about any of that. Okay. And this is the ends, and we don't even need this shit. Okay. So if we reach that, it means we reached this or no. And here we can say expected that at the end of an array, right? And here we are 100% sure we reached the end of the array, so we can just copy the code responsible for that, which is basically the patch of array start, and that's it. Oh fuck, but yeah, okay, yeah, I forgot to copy. I forgot to copy these sheets. Yeah, so I can say that. I can even inline it like this. Okay. So that is also handled. That is also handled. What else? I just need now the immediate stuff, right? And for the immediate stuff, we just do something similar, I guess. I'm gonna copy everything just to be simpler. Let's copy all of these sheets. Like so. And fuck, okay. This fucked up the format, but all right. So we can keep reading. It's okay. If it's all digit, here we are 100% sure we are in neither of these situations, so we can just say that. And we can continue. Sure. Here we don't need this. Then here, sure. Here we are 100% sure we are not inside compilation mode, so we just need to call like that. Sure, we can keep this, and here we can even inline it, just be a little bit shorter. Okay. Then if it is that, we can just defer it to compile words. Right. Exactly. Then if it is that, we can report an error, right? So we can just say error used error outside of words compilation of word definition, actually. Right? We can just say that, and we can continue. So we don't need any of these. Man, I don't know if I want to call that word definition or word compilation. Like, I'm a bit mixed with the naming. Word definition. Yeah, I'm gonna call it word definition. I think it's word definition. It's a lot more straightforward. So if we reach that, we just compile a quote. So we can call compile quotes. Bam. If we reach these, we can report an error. well, here I don't even need continue. I can just say that. Yeah. Used that outside of quotes compilation, or outside of quotes, outside of a quotes. Then why did I jump? Okay. Then that case we just do compile array, and in this case it's the same stuff, same sheet, so we can just say used outside of array of a yeah, outside of an array definition. Okay. Then we can keep these for debugging, and everything else we can say unknown word. Sure, we know for sure we are not inside compilation mode, so we can just say that, right? Yeah, so it's a lot cleaner, I would say. It's a lot cleaner. Why are you, oh yeah, missing stuff like that. Okay. Sure, and here we can say compile quote compiles the following constructs, and in this case it's going to be that followed by body, and these compile the following constructs number, right? And that's it. That's the entire construct. So yeah, I think that's the refactor. Let's comment all of these sheets, and now we can also comment all of that. But, okay, and now if we call compile, or actually immediate words, yeah, because this already has a loop inside of it. I don't know if I like it or not, but yeah, whatever. We can keep it like this. Here we need that. Okay, yeah, can keep it like this for now. So if we, okay, it's okay. In this case, it's wool size of type. What else? Oh yeah, fuck. So this case, I'm gonna call it, what am I gonna call it? W, I guess. Yeah, sure. Okay, so if I do that, it should throw it. It didn't throw an error. Oh, because it identified it. Okay, it identified it as a name. Okay, we can actually check that. So we can check if straqs is equal to one of the reserved characters. So this is a reserved character. We can check a bunch of them. Well, yeah. We can check all of them in a single line. If it is that or that, or that, or that, or this, or that, in that case, error name of cannot define redefine reserved character, right? And here I can say which ones are the reserved characters. So I can say that, that, and I think like dupe and all of that, it can be redefined. Maybe, I don't know. We can check it. We can also check. Yeah, we can also check if it is a primitive. But yeah, I don't know. Cannot redefine character. Yeah, sure. And here we can return, like so. So if I do this now, okay, error cannot redefine a reserved character. Here you can say found, or actually caught. Well, I think it's pretty explicit what's going on. All right, so if I refine a word that there's 1 plus. Oh yeah, now it's pulling up. Because it said expected stack effect. Okay, yeah, that's true. So my words now need a stack effect. So I can say that it consumes 2 integers and outputs an integer, and this is just going to do a simple equals. I don't know. Okay, it didn't complain now. So if I have 0 and 1 and I do words, I get segmentation fault. Why is that? So is it when I do this? No. So it's when I call the word, right? It is when I call the word. So if I have a word 0, bam, 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 like this. Right. Okay. So it's when I call a word. So how am I doing it in immediate mode? So words. Well, it should be okay. Is it because I fucked up somewhere? Probably. Oh yeah, maybe. Did I correctly set the bumpy? Yeah, I did. I did set the address correctly. Okay, so let's check the following. I define these words. By the way, does this work? Maybe like an empty. Yeah, maybe it's easier to do this. Let's see if I support it. Yeah, I do support it. Okay. If I do this, oh, there is no C. Oh yeah, there is no C3. Okay, I see. There, I never returned. I never returned. So I'm missing. I'm missing something. Code appends. Right. Yeah, that's what I'm missing. So I added it to the quote, but I didn't add it. Yeah, exactly. I didn't add it to the word definition. So now if I do W with an empty stack effect and it just pushes 0 or something, and I call W, yeah, it's no longer going to complain. Okay. So if I have W with something like int dash dash int, and this just does an equal or something, I guess. And if I do 0, 1, W, I got 0. They are not equal. Okay. Everything seems to be correct. So now we can take all of this shit away. We can even say, I need to think about these names. I don't like these names, but okay. So now we just need to keep track of the types, right? We need to keep track of the types. Let's have, where do I define my stack? I define it here. So I can have something similar. I don't even know. I'm gonna put it here to not pollute like the code that is above. I'm gonna put it here and I'll say, okay, type stack types, and it's actually types. Yeah, that's actually types. And this needs to be like that, right? So we actually need to place it either there or somewhere. Okay, let me show you. This name is like it's giving me OCD. I'm gonna call it loop, or I'm gonna call it REPL. Yeah, I think REPL is even a better name. Okay. So this is the REPL. Much better name. So this sheet can actually, doesn't need to be there. It can actually be here. It needs to be a global variable because we are this allows like we can have recursion inside of this. So we need to keep track of that. Am I resetting even? I am not. I also forgot that. Oh, because I don't need to reset because this is decreasing. Okay, yeah, that's okay. So do I want? Let me think. So here we have this. Let's have something like void init memory segments, something like this. And this function just does this shit. Yeah, just does that. Fuck. And here we, okay. Well, we can keep it, we could keep it, like, yeah, we can keep it in a global variable. I don't see a reason to not do it. Okay, so we can say const, this is a const, I can even say const pointer, right? So we have it quite well defined, and then here can have const, sorry, this bump the start, and this can be sharp const pointer as well. So then when I initialize my memory segments, I just do this shit, right? And so does init memory segments after I init the primitives. Okay. Then I need to do that. Okay. I need a function to put shit into the stack. So I need to push types onto the stack. Oh, it's already, yeah. So I can here, I can say types underscore append, and this case is going to be oh fuck, this is going to be like an array of strings, right? So let's just push to integers for now and say type int and like this, and I can say to do fix this is actually an array of strings, but we don't even support strings right now, so no needs to overcomplicate it. All right, so when we are inside our REPL, we need to keep track of all of this shit, right? So if we push a literal, we just do this, right? If, oh fuck yeah, we need the signature of all the primitives. Now that's also important. So we need to move the types upwards. Where did I find my types? It's here. Okay. So I can say, where are they? Probably here or somewhere like that. Okay. So I basically need the following. Here I need to do inputs and I need outputs. Something like this, right? I think so. And so dupe. Oh fuck, I need like the any type because I can like identify. So dupe works on any word, right? Yeah, so we actually need another type. Let's say type any, because there are words that are like how do you call it in terms of programming language, like polymorphic or something? I think that's a name that people use. But anyways, here we need to say input, and we just need to define. Can I like statically? Well, but this is already a dynamic array, so anyways, we can use the function we already have. So this is going to consume type any, like so. And output is going to be type any followed by another type any, right? This out, and that's in. Yeah, then drop is going to consume a thing, but it's not going to return anything, so the out thing is going to be empty. I need a better way to like define all of the primitives because this is getting super ugly. Yeah. Then for swap, like the stack remains the same, and but either way we need to define it, right? And it's also any, so it's like a polymorphic thing. Then equals works for integers. It does not work for quotes. Fuck, we already need. Yeah. Does it also? Well, it doesn't also. Yeah, it doesn't work for arrays because like we can compare pointers, but that doesn't have any meaning. So equals for now is only going to work for ints. Oh fuck. This is equal, and type is going to be ints. Yeah, and then we can have like polymorphic words once we have something more or less working. This is going to be the same, so all of these are just going to work for oh fuck, and this actually takes 2 arguments, right? Takes 2 arguments and outputs a single one. So 2 arguments, and this is all okay. Like, what am I doing? Control C, and then that's there. So it takes 2 arguments and outputs 1. Same here. Yeah. Okay, that's a lot of shit. Okay. So lesser equal, same shit. Then if, what is if going to do? So if, it's a very interesting case because if, fuck, how am I going to even type check if? Like if is a very special case because like like it depends on the quote itself. It depends on the quote. And the same thing for when, and the same thing for apply, and for. So maybe what we actually want, instead of having this shit, we actually want something slightly different. So let's move this once again lower. Where do I want to have it? Here. And let's do the following. So instead of having types, we can have like a function pointer. Let's say type def bool I don't know, like check or type check, right? And this one is not really going to accept anything, so it's basically this. Okay. So can I like a type check? I can even use the notation we generally use, and I can say type check, right? And then we are basically going to need a function for every single one of these. Every single one of these. And yeah, I'm actually going to need, I'm actually going to need the types above. So yeah, I'm going to need the types here. And I no longer need the any type. I no longer need that sheet. But in here, I'll basically be forced to do the following. So void, or actually bool, dup type check, right? And this is going to accept some stack of types, right? It's going to accept it like that. We can even mark it as constants. So this one is actually incorrect. It needs to be this. So we can even say const. Okay, so well, you are supposed to modify it, so it even should accept it as a pointer, like so. So in that case, yeah. So these types, I forgot to copy the function, didn't I? So yeah, this one, types append. So this also is useful to have it upwards, like so. And basically what this is going to do, like this is going to do if stack types dot count is less than 1, we need to report an error. So we can say printf error loop requires at least one element inside the stack, the data stack, right? Something like this, and you can return false. And then we can just pop it, to be honest. Yeah, because like is that any notation, right? We don't really care what the fuck it is inside of it. We just care if it is at least 1. So that's okay. And so for the Jesus Christ, it's going to take so long. Okay. For that, we can say type check, and here we can just assign loop type check. Okay, and we basically need to do this for every single one of them. So if I say drop, oh, here is not really count minus minus, is actually, okay, is actually types appends into stack types. Whatever is in stack types, stack types, okay, data stack types count, right? -1 actually, because one's the current element. Yeah, and we need to do that twice. We can even, like, if you want, extract it into a variable and just say, oh, we don't need to do it twice, we just need to do it once because we are just duplicating or triplicating, so we can do that. Cool. Now drop, yeah, we drop, we can just remove it. Then we basically need to do all these sheets. Okay, so drop, check. What else? Swap. Fuck. Swap is a very interesting case because it requires 2 elements, at least 2 elements inside the data stack, and here we actually need to extract them. So we can say type A. So this is A, this is B. So basically we AB, and we can say the following. We can actually say the following. So we saved A, so that's our temporary variable. We can copy B into A, and then we can get A into B. So that's the swap type checking. Okay. Cool. So we can do that. Swap type check. Then we need equals. And here we can say, you can say something like bin up type check. So it's like easier and I don't have to write so many functions. Const char, you just say op, and here we can just literally just print the op. It's so much easier. Okay. Requires at least 2 elements inside the data stack. Yeah, should I have booleans? I can have booleans. I guess. So int type bool, like this. And this is like cons, right? In that case, so it is a condition binop fucking. Okay, condition binop type check. Yeah, I guess. And in this case, it is required that both A and B are basically integers, right? I think so. So if A is not equal to type int, or B is not equal to type int, we can just report an error. Oh, and I'm forgetting to return true at the end. Fuck. I can do that everywhere. I can just do this. Yeah. Like this. Okay. So here I can say requires the top 2 elements of the data stack to be int, to be of type int, something like this. Okay. And then we can just like copy and paste all of these sheets everywhere. So let's try to even do a little bit of magic. So we so is this, yeah, this one is a pattern that we use. So greater equal, less equal, and that's everything. So move to the end of the line. Actually move to the beginning of the line, lower. Then we can do multi-curse, or we can also do that, and get rid of that, get to the beginning, copy all of that, go to the end, then we need type check, right? And here we're going to do cons binop type check. Oh, but it fucking needs, god fucking damn it. It fucking needs the thing. It must be fucking kidding me. Okay, let's do the problem. Define that as being that, and this is basically name and op, and here we need name concatenated to that sheet. Here we can just do that. Here we need them not actually that, and we need to concatenate op, concatenate, and we don't care. Isn't this how? Oh, we don't even need to concatenate. We can actually do that. Yeah. That's actually good. So here we just need the shit. Fucking, I swear to God, Jesus fucking Christ. Okay, then that's what else? Here we also need the fucking up. That fucking damn it. Okay, and then we can just call the fucking macro and generate the functions in the preprocessor. In here we don't actually care about op. Right. Yeah. It needs name and op. So you're going to have equal and say EQ and op is that one, and basically just do that earlier. Oh wait, it's not liking it. Okay, because this is actually like this. Yeah. So we have equals, we have GT, which is that, GTE, which is that, and then we have L less, yeah, ls, I guess, whatever. I don't know the exact mnemonic that it is used, but all right. And then here we can just basically say the following. I expect EQ type check to exist. Okay, fucking, and we can just do that. Okay, and then this is GT. Okay, at least that. This is GTE. This is ls. I don't know if it is like less or whatever. LSE, I guess. Okay, finally, for fuck's sake. Then for if, it's going to be like a special case because we currently do not have types inside quotes. So let's just assume that if needs the following. So if needs the condition, it needs two quotes. So it needs to at least have 3 elements inside. So if requires at least 3 elements, 2 elements here, 3 elements inside the data stack, and then we can type check it actually, like the following stuff. Oh, and by the way, here I forgot that then yeah, we can do this minus equals 2, and then we can actually push stuff, right? We can just say types append, and we can append there, and we can say type bool. So we're going to append a boolean like that. So then yeah, we can extract all of these sheets. So A, B, and C, 2 and 3, and we can say the following. We can have something very similar. So A needs to be a quote, yeah, because A is the top. So yeah, type quotes. B is quotes. C needs to be a quote. Actually, boolean. So error if requires the top three elements of the stack to be of type. Oh, here I can even say bam. Right, I can even say that. To be of type int, right? And here I can say to be of type bool, then quotes, and then quotes. Yeah, it's a decent error message. All right, so this is how we are going to type check if. We cannot like do anything else because we don't support it. So type check if type check. Okay, then the when is going to be similar, just slightly different. Yeah, and here like let's assume what the fuck are we going to assume? Let's assume the following. So count minus equals 3 and fuck it. Here we need 2 elements inside the stack. We can say that. So it's going to be that 2 elements inside needs to be bool followed by a quote, and then you can just pop those 2 elements. Okay. Fuck. So this is the when type check. Okay. And here, like, I'm gonna put a to do appends whatever the quotes push. Yeah. And here the same shit. Then we have the apply, which is also a very complicated case. We cannot really type check it at the moment, but at least we can confirm that shit is inside the stack. So apply requires at least 1 element inside, and in this case it needs to be quotes. Oh fuck, here I forgot, so it needs to be a quote in the beginning. Right, how did I do this? Yeah, type. Oh, it's the other way around, right? Oh no, it's correct. So B is the last one. Okay. This is not if, this is when, and this is apply. The top elements of the stack to be of type of quotes, and then yeah, same sheets. We already have like a lot of primitives. I was not aware that we have so much stuff. So this is the apply. Then we have for which is, yeah, the almost the last one. Okay. For requires so 2 integers plus a quote, so 3 elements inside of the stack. Here we care about, let me copy it from here. So bam, okay. And this needs to be the following. Okay. So we need a quote at the top, and then we need 2 integers. Right. And here is for requires the top 3 elements of the data stack to be of type int quotes. Right, if I'm not mistaken. And here we can, again, same sheet. There is nothing we can do. Yeah, so we can just take that, and this can be for type check. And finally, cat, we can get the length. And do I even have arrays in here? I think I have arrays, don't I? Array, yes, we do have arrays. Okay. Okay, that took me like 20 minutes or something. Jesus Christ. So that's the length. And here I can say, oh fuck, what am I doing? The fuck is this? Okay. I'm not even updating this, so this is for, this is apply, this is when. Okay, and apply for length. So the length requires just 1 element inside of the stack, and that element needs to be an array, right? Begin with. It needs to be array, and then the top elements of the data stack to be array. All right, and here I can just, well, actually, I can just say that this guy now becomes an integer because that's what the length does. So we can do type int, and here I don't actually need it to do. Cool, cool. So actually trim. Yeah, and here I just need to do the final stuff. And this is going to be length type check, and this is length. Okay, we don't need this because this is a special case. Okay, so let's fucking go. Let's handle the REPL first. So this is a special case, it's handled. Then in this case, what do we need to do? We just need to do p dot type check, and we just type check with the stack types. That's it. That's the entire implementation. So that's why we did so many functions. Then this one doesn't do anything. This one doesn't do anything. This one actually, yeah. So we are in REPL mode. So since we are in REPL mode, we need to say that, I actually need to copy this. This is going to push a quote, right? So quotes, and here to do, well, yeah, we can actually keep it like this. This is an error. This is going to push an array, right? And then once we find a word that exists in the vocabulary, we just need to push. Well, we actually need to do two things. We need to compare if the two types things are the same. So let me check. So if we push that, that's going to be a yeah, that's correct. So we need to, well, we can do types equal or something. Well, we can actually put them here because I want to have like actual printfs and everything. So void types eq, and here we can have types a, types b, like so. And we just say, okay, well, types stack and inputs, like words, type check stack, and word inputs. So it's probably better. So this is going to be the stack, and this is going to be the input, right? And this is types. So if the stack dot count is lower than input dot count, we can instantly report an error. We can instantly say error like do I, yeah, we can const char words, something like this, and we say expects these amounts of elements inside the data stack, but only these amounts were found. Or you can like always report the mismatch, right? Yeah, I mean, we can report the mismatch. We can say void report type mismatch every time, so it's like more explicit. Yeah, so you can just say for size t I equals 0, I is less than stack dot count I plus plus, and we can say so we can write print stack that yeah, let's say that, and then let me do a nice thing. Where is it? Okay, let me do the following. So type counts. I can just say const char pointer type as str or as cstring, and this is going to be type count is equal, and then I can say bam type int. So it's, I think it's like, yeah, it's much easier to handle this bool array code for now, because yeah, this will be useless in a few hours, but anyways, because then we are going to have like composite types for codes and arrays, but for now it does the job. Okay, so yeah, here we can just say type as that, and then we can say stack data I, and you can just print as that. Yeah, and print it like that. Here well, that's already going to add it, so then we can have this, and here we can even print the size of the stack, right? You can say stack dot count, and then this is just the final thing, and then here we do the same for input, right? Yeah, basically that. And so here we can say error mismatch between that inputs and the data stack, right? And we can say that. Then we can report the type mismatch between the stack, the inputs, and we can actually fail. So we can just say return false. Okay. Then we know that the stack it is at least as big as the inputs. So we can copy this and we can check. Yeah, so if inputs dot data I not equals to stack dot data I, right? If that's not true, we can do the same shit and we can return false. Okay, and then yeah, so if we want to type check, we actually need to receive well, we already received the stack here. Let's just receive as a pointer. It's actually going to be necessary. And here we can actually dereference it, because now so what we need to do, we need to stack dot count minus equal input dot count, and we actually need to also receive the well, at this point we can actually receive the words, the entire fucking word. So words, right? Okay, I think it's easier. So we get the stack and then followed by the words. Okay, so here we just need to say words dot input, and we just do that everywhere. Okay, and here yeah, I forgot to add this. This is words dot words. Like so. But then we can like take away everything that's inside there, and we can assume that the word actually is properly type checked. So we can just say for, well, it's the same shit. For that, we can do types appends, and we need to append to the stack the type of this. So, and finally we return true. So this is how we are going to type check a word. I know it's a bit ugly code, but it does the job. So I should actually call this before. So this is going to be stack types. And my words is this thing. Oh, it needs to be a pointer, right? Okay. And so we can always say if not that, just return, yeah, basically. So if we were not able to type check, instantly return. Oh, and this thing, yeah, this thing is just going to push. This thing is just going to push. Yeah, because we are only going to handle the REPL right now, I feel like. So even this, yeah, this is just going to handle to push, but here we should do it before calling, and if not that, then return, and that's it. Right, we return from the REPL. Yeah, so let's test how this is. Fuck, okay. Discards const, that's fine. So we can literally just say this. That's fine. What else? That's fine. I just want to have warnings so I can cast because I know what I'm doing. So I can do that. Okay. Okay. So now, now what do I want? Let me think. So I currently have two elements inside the stack. So if I do, for example, an equals, it's going to allow me to do it because those two elements were valid. But if I try to do another equals now, it should report an error. Okay. Equals requires at least two elements inside the data stack. Yeah. I can even like report the mismatch maybe. Well, I can have like let me think. Void print stack or types stack. Types print. Yeah, can we just type print? And here we can just receive types, the S, and we are just going to do this. So bam, but without all of that shit. And this is just the S. Then here, sure, we can do that, but oh yeah, I can do that. Type print the stack, and here I can printf new line actually because I had forgotten a new line. So here I can also print a new line. So then if we encounter a problem with a primitive, we can actually report an error, and we can say in F, or we can just say, yeah, print stack types types stack. What was the stack types? Yeah, stack types. But we can like prepend it with we can say printf we can say like error current stack is and you can just do whatever that says, and then printf, something like this. I don't know. I'm not very creative right now. Okay, too many arguments. Yes, that makes total sense. Okay, so if looking at why are you showing me links? Okay. If I do an equals, it's going to allow me to do it. If I do another equals, okay. Equals requires at least 2 elements inside the data stack. Current stack is bool. Okay, okay, that makes total sense. Let me just do the following. I want to wrap these messages with this, so it's easier to identify exactly what's going on. So I need to fetch everywhere, and then apply, and when, and same step. Oh fuck, the if requires me to do it by ends. And here I can actually also wrap it. Okay. And I still need it here. Same stuff here. Same stuff here. Okay. So we did that. Let's try again. So if I do equals equals, okay, equals requires at least 2 elements inside the data stack. Current stack is bool. Actually, let me do the following. So I can say I can say, what can I say? Info instead of error. Yeah, info. And I don't really want to return here. I should actually just read the next line. So let me say continue. We should, well, no, yeah, we can parse the next word, that is. Or maybe we should like discard the current line, right? How do we even discard it? Well, that's actually easy. That's actually easy. We can change a little bit this, and we can say discard line, right? And to discard a line, we just, so this is not going to return anything. It's void. What is the fastest way to discard a line? Well, we need to keep track of the next, basically. I don't see any other way. Well, we can actually set is first to true. So yeah. Actually, we should just say is first equals true, because if it is first, this is going to do tib, and tib is going to be, oh no. No, that's actually not true. So yeah. Yeah, let's have the following. So sharp pointer underscore underscore next. You just keep track of it like an internal state, right? So you can have like an internal state, and this is static. All of this shit is static, and this is also static, by the way. And so here we can say next equals results, because then we can simply say, oh no, that's not good. That's not good. Let's do the following. Let's go the easy route. Mem set tip to be equal to that, and this is going to be tip size. Bam, that's it. Discard line. We just discarded it. All right, so every time we encounter a problem, a type check problem, we can just discard the line. Yeah, so this is basically it. We can just discard the line and we can continue. Okay, so we do not terminate the stuff there. And here we can do the same stuff, right? So instead of returning, type check stack, we can actually improve this by saying the following. First we discard the line. We can have the same message. Info current stack is bam. So then error mismatch between input and the data stack. Sure. Well, all right. And here in the report mismatch. Okay, I guess. But then I should, in that case, prepend this with info. Something like this. Info. Yeah, I think it's probably a better thing. We can clean like all of these logs like that. I'm still trying to sketch out how I want this to work. So bear with me. All right, let's try again. Now if I do equals, fine. If I do another equals, it okay. Well, it didn't actually. So discard line didn't actually work, right? Huh. That is interesting, actually. That's actually very interesting. So tip begins. Oh, because yeah, I need to set. Okay. Okay, yeah. Should read line. Something like this. Is that what you want? Because I need to force this to trigger. Not really. Well, it depends, right? It depends. Is this going to... So if I do that... No, it's still fucked. So wait a minute. So let's keep this is first. But then instead of mem setting, let's see. Is discard line. I'm gonna set it to false. Let's just save this for now. And here, if we just say if is discard line, if it's not, yeah, I'm thinking how can I structure it? So I need to extract this there, right? And then this, and then that, and that, and then that, right? So if we are trying to discard the line, right? And you can say is discard line false. Right, and this can be initialized with no. So if you're not trying to discard a line, we can keep reading from that line. Then we reset that, and then here we exhausted the line and you keep reading. Okay, that may actually work, so let's try it. Unknown word. What the fuck are you trying to say? So is there a... Maybe there is a problem with my REPL. So... Oh, I see. So found primitive fuck. So it could actually be working. Well, but this implementation is actually faster because it just sets a variable. So yeah, let's just keep it like that. If I do that and I add a bunch of spaces, yeah, now it's working. Okay. So error equals requires at least 2 elements inside the data stack. Info current stack is bool. Okay. So if I push, I don't know, a 0 and I try to do equals, it's also going to complain. Error requires the top 2 elements of the data stack to be of type int. Current stack is bool int. Okay. So that's actually quite reasonable error reporting. Like it at least we know what the fuck is going on. So if I push another element onto the stack, let's say 1, and I can just print it. So we have 0, 0, 1. We can say the following, or we can say, I don't know, greater than. Okay, can do that. And now we have 2 booleans. Like we don't know that these are 2 booleans, but we get that. We can actually say the following. We can have where is it, the REPL? We can have another debug command that is like .t for types, and then we can say, where was it? Where was my, okay, this, yeah, can just print the types, and we can, am I adding, no, I'm not adding like an indentation, so it's okay. Well, I could add indentation actually. Let's add indentation to both of them. Yeah. So if I do equals, okay, if I get the type, we get a boolean. If I now push a bunch of numbers, and I get the types, okay, I have a bool with 4 integers. If I get this, I get exactly the types. Then the actual values. Then so since we have 2 booleans, I can say something like greater than, and this is going to be boolean int. So I can do swap, I guess. Yeah, swap is, yeah, swap should work. So now I have bool int, and if I get the values, okay, that's correct because I compared these two and then I got 0, 0, 1, 0. I swapped, it's actually correct. Then equals should not work, correct. Then if I push, I don't know, I can do drop. Yeah, drop is working. What else? So currently I have a boolean and an integer, correct, because I dropped these two. Dupe, is dupe working? It is apparently working. Yeah, it is apparently working. It is in fact working. So if I do 0, 0 equals, and then, so I have a boolean on top of the stack, and if I do dupe, I now have 2 booleans on top of the stack, and they should be equal, correct? What else? Is there any other primitive? Like, I could try the if, but the if shouldn't really work that well, because we are not like pushing whatever elements are returned by the quotes. So, but we can try that. So we can say that's 1, and this is going to break the type system. Yeah, because now we have so this, okay, but this is should be an integer, and this is going to be a mismatch, completely mismatch. Yeah, so it consumed this one plus this one, right? So the boolean and 2 integers. This one is now, wait, why is it yeah, it is a boolean because, so 1, 2, 3, 4, 5, 1, 2, 3, 4, exactly. So it consumed one of the booleans, 2 quotes, and it didn't push anything onto the stack. So this particular quote application is not being taken into account. But I mean, it's fine. Like if we have something like this, we do 4 is also not going to work. Like it's going to execute it correctly, but the types are going to be all fucked. But let's try it like arrays maybe. So if at this s, that's not correct. Oh fuck, arrays are not working. Okay, so I fucked up something in here. Oh, I forgot fuck, and I already deleted the code, didn't I? Well, but it's basically the same as here. Yeah, it's basically the same. So I actually need to push it, right? So if it is inside the quote there, so here I don't need to patch. What the fuck do I actually need to do? Let me think. So yeah, it's a literal, and the literal is basically so int64 or yeah int64 i64. So yeah, in the copy paste I totally forgot this. What the fuck? And here leads that and that, and then we don't actually need any of this. And this, let's say that, yeah. So this was what was missing, I believe. Let's try again. Oh, okay. Oh yeah, we need to explicitly cast it. Okay. int64. Let's try again. So if I push this, this is working now, and my type has an array inside of it. Okay. So if I do length of that, I get 1, and my types have an integer. So the length is working. So the arrays, the words that work on top of arrays are in fact working. If I have like something like 0, 0 equals, and I call length, it's not going to work because length requires the top element of the data set to be of type array. Current stack is int boolean. So that's working. So the only thing that is not working is basically the quotes, right? So the quotes and the branching, because that's a bit harder. Let's now, to end this video, let's try the last one, which is the word definition, right? Compile word stuff. So if we define a word with the following signature, so int, and it produces an int. So we can even call it drop, or I don't know, cmp or equal int, something like this. Okay, we get int, bam bam, and this is going to produce, fuck, this is actually going to produce a boolean, isn't it? Yeah. Oh, by the way, we are not actually still type checking the interior of words when we are compiling them. That's still missing. So let's do something simpler. We can say dup int, actually. Okay, dup int is going to get an integer from the top of the stack, and it's going to produce 2 integers. And this is just going to call dup as is. Okay, so that compiles, which is good. And now, currently I have 2 integers on top of the stack, and those 2 integers are this. Okay, so if I call dup int words, it's going to execute the types. Oh, this is not correct, is it? Shouldn't my vocabulary take that into account? Did I fuck? Oh, I think I fuck up. Oh, yeah. Wait a minute. So here, what am I using? Yeah, it's not input. So you see, this should be output actually. Okay. Yeah, that was the bug. So let's try again. So if we define a word saying loop int, which accepts a single integer and it produces 2 integers, and this is just a wrapper around loop. And then if I say, okay, this is my types, this is my values. So I have 2 integers. I call loop int. It executed properly. These are my types, these are my values. That's everything is fine. But then if I do an equals, right? So my types now become, on top of the stack, now become a boolean. If I call the dup int function, it should fail. It fucking worked. Fuck. Why did it work? Oh, because I'm doing this in the wrong way. Yeah. So one last thing. So here, I need to say I need to get the difference, because like if the stack is bigger than the input, the expected input, we actually need to subtract the difference, right? So we need to say, okay, this is the diff, or we can call it the offset. Okay, offset, and the offset is basically going to be the difference in size. So if the stack is bigger than the input, this should be yeah, that counts minus that, right? And this is basically a stack offset when we are type checking. And here we basically need to subtract the offsets, right? And well, here we could also do that. So, well, but yeah, let's just keep it like this. We can improve the code later. I just want to make sure that everything is properly working. So let's try it again. Do ints, which gets an int, and puts two other ints on the stack. I currently have the following. So integer, integer. If I call do ints, and I do this, I get integer, integer, integer. If I compare the top two, I'm going to get an integer and a boolean, so these two are equal as expected. And now if I do loop ints, fuck, it still worked. How did it still work? So the expected input is, oh, this is not, fuck, this is not subtract, this is plus, right? So if the stack is like there's one extra element, like is bigger than the stuff, I need to move index. Yeah, let's try again. So all right, if I do this, and bam, then I do int, then I do that, all right, and I do an equal, we get this, everything is fine. Do int, it should fail now. Okay. Mismatch between dup int input and the data stack. Info stack has two elements, int bool, input as is expects an integer. And then I'm also printing the current stack. I shouldn't really just print the current stack, to be honest, because I'm already reporting it there. So let's see. Yeah, here. Yeah, this one is actually there. Yeah, exactly. Like, but everything else is working. We can even do one final test. So let me just put that. We get this. We fail. And our stack. Oh, did it execute? Oh yeah, because fuck, here I need to continue. Okay, there was another bug. One extra try. Let's go. Loop int. Well, let me first show you the stack. Well, let me do the following actually. To have a clean state of execution. Okay. Fuck. This is not what I want. Okay. Can I leave? Just okay. It's working. Dot t dot s. So this is my stack. Loop int dot t dot s, this is my current stack, equals dot t dot s, this is my current stack, loop int, it fails, and if I check if the stack was changed, it wasn't, so the stack remained the same and the function did not execute. Yeah, so that's already working. And this works for like whatever complicated function we have, as long as we don't use quotes or branches. That's something we'll need to work on the next video, to be honest. Oh, let me check one thing, by the way. So just to confirm, if I do that, yeah, it's a very small function, and this should only actually copy this. So this is going to inline everything as expected. Okay, all good. So yeah, we just refactored a little bit this episode. We created our REPL function, we extracted some stuff. Some code is still ugly, but we will improve it as time moves on. At least this one is a lot cleaner. This REPL function is a lot cleaner. We also abstracted this compile code function, which is in single place. We now have a compile word, compile quote, and compile arrays. Oh, and by the way, does this work if I do the following? So if I have a word and I say push array, and this basically doesn't get anything and it just pushes an array. I don't even know if, yeah, okay. So this is my current types and stack. If I call push array, I'm gonna get fuck. Why didn't, yeah, I'm glad I checked it. So push array, why didn't you, it should have done it. Okay, let's see. Well, it should have worked, shouldn't it? Am I not appending it? Let's do the following. So printf. Let's do it like this, just to finish the episode in with everything like properly working. If I do it like this, out, right? Yeah. Let me extract this into a file. Fuck. And even put everything in a single line. Yeah, why not? So I do that. Oh, out is 0. Oh, I see. And since out is 0, and why the fuck out is 0? Let's check the compile words. Oh, because this is, okay. Well, we should report an error in here, right? We should say printf error unknown type. Fuck. Why can't I, what? Okay, this is the key. I need to, we can say that it's better, I'd say. Yeah, we can say that, and then we just print the type, and we can return. Here, these functions could actually return a boolean, to be honest. So we can discard the line at the REPL level, but I don't know. We can change that later. Oh. Okay, unknown type array, and then it started complaining a lot about a bunch of stuff. So let's change that. If I do this now, okay, now it knows that this is an array. Okay, it is working now. And we could also support booleans, by the way, but the fuck did I wanted to do? I wanted to remove this, and I just wanted to add the support for booleans. Where was it? Okay, so that's bool and bool. Okay, so this is a very basic type system. Like we have integers, booleans, and hard-coded interarrays, right? So that it's not like that. I can say like GT, for example, it gets two numbers, bam, bool, bam, and just does greater, for example. Oh, like so. So I mean, it's something, I guess, but it's completely dysfunctional. Uh, yeah, we still need to work a lot on this. We still need to work a lot on this because if I do this, we have two integers in there. I do GT. Okay, we know it's a boolean, but everything that is useful, for example, quotes. Let's say that 6, 7. If is broken, right? It just consumes stuff from the stack. It doesn't know that 7 was pushed. What else? The for loops are also fucked. So if I say 0 to 5, or even I can say that, so 7 is already on the stack, it's 0, swap the both, and I just have like an empty quote. So this is going to have like indices being pushed onto it and not being dropped. If I do this, oh, it complained. Oh yeah, because again, like it doesn't know that the type's fucked. Okay, so if I say 0, 5, sure, and I swap, well, what is currently on the stack, by the way? A single integer. Okay, so it's okay. I can do that in that case. And that 4. I do this. We get this. So this is completely like fucked, right? And the same thing for the when. So anything that is a quote and branching is completely fucked. Everything else is pretty much working. But yeah, so we need support quotes, we need support branching, we need probably to support proper types in here. So we could say this is one type of array. We could have other types of array like boolean, right? We could have boolean array. And we could do optimizations in the future if we supported boolean arrays. We still need strings, right? We don't even have strings in without types, much less with types. So we need something like this. We need something like this. We need something like this, and this. I don't know, like for example, my quotes. I don't know if I'm going to like begin the quote with some type declaration. For example, if this quote is inside of for, or if it is going to be used by a for loop. I could do this. In fact, I could do it and then have something like this, right? And then I can like format it in a way that is not completely like more or less like this, maybe. I don't know. I need to think about it. Or I could just extract the type signature of a quote while it is being compiled, so I can like do type inference. I can do type inference. That's also an option. Yeah, that's an option. And it's probably what I'm going to do. I'll at least try to do. And after that, I think we have everything, to be honest. Yeah. I think we have everything. So it's not that fucked actually. Yeah. Alright. So it's probably going to require me still like 1 or 2 extra episodes to have this finished properly for the types. And after that, I don't know. I may like make a small pause because I'm already getting tired of uh this project. It was like a lot of days straight programming just for this. So I make a small break. I don't know. And here we have a bug actually. We need to check if it's equal to that. Um, we need to check a thing. So if current type is not equal to that, okay, we do it. Else we need to report the error. We need to say used at more than once inside stack effects of, I can even say that. Okay, I can say exactly the word. This is S, right? I don't use S anywhere. No. Okay. Of S definition. So if I now do shit like this, so W, bam bam, I can say like int, bam, int, and another int. This is going to, yeah. So used more than once inside stack effect of W definition. All right. So yeah, thank you for watching, and I'll see you in the next one.